Hello everyone, welcome to Augment Tech. In this session, we will be learning about Python NumPy, ufunc rounding decimals and ufunc logs. By the end of this session, you should be able to understand rounding decimals, truncation, rounding, floor, ceil, logs, log at base 2, log at base 10, natural log or log at base e, and log at any base. I'm excited to get started and I hope the same from you. Let's get started with rounding decimals. So there are primarily 5 ways of rounding off the decimals in NumPy. One is truncation, then we have fix, rounding, floor and ceil. We will be learning about all of these one by one. Now let's see what is truncation. So here we remove the decimals and return the float number that is closest to 0. Here we use the trunc and the fix functions. There we go. So here we can pass some values to np.trunc and this is going to truncate and give us the output. Same as with fix, when we do np.fix and then give the values, it will truncate and return the output. Now let's see what is rounding. So the round function increments preceding digit or decimal by 1 if it is greater than or equal to 5, else it will do nothing. For example, rounding off to 1 decimal point when the number is 3.16666, it will round off to 3.2. And there we go. You can pass the numbers to np.round function and it will do the rounding off. Now let's see what is floor. So the floor function rounds off decimal to nearest to lower integer. Floor is, it will be rounding off to the lower integer. For example, floor of 3.166 is 3. Similarly, we have ceil. So the ceil function does the opposite of floor. It will round off the decimal to nearest upper integer. So the ceil of 3.166 is 4. Now let's see what is NumPy logs. So NumPy provides functions to perform log at the base 2, at base e and base 10. We can take log for any base by creating a custom universal function. All of the log functions will place minus infinity to infinity in the elements if the log cannot be computed. Now let's see what is log at the base 2. So here we use the log2 function to perform log at the base 2. So here in this example, we are printing the numbers from the or in between the range 1 to 10 and then trying to find the log of base 2 of those numbers. And then let's see what is log at base 10. So here we use the log10 function to perform log at the base 10. And then we first get the elements or array between range like say 1 to 10 and then we will try getting the log to the base 10 of these numbers between 1 to 10. Natural log or log at base e. So here we make use of the log function to perform log at the base e. So again we can just go and say log and then the range of elements in specific range like 1 to 10, it means it will print from 1 to 9. And then log at any base. So NumPy does not provide any function to take log at any base. So we can just make use of from pyfunc function along with a built-in function like math.log with 2 input parameters and 1 output parameter. So here we are importing log from the math module and then we are going to say np.fromPyfunc to which we'll be passing the log with 2 parameters, 2 input parameters and 1 output parameter and then pass the values to the variable np.log. Now let's hop to PyCharm and check out the example of NumPy rounding decimals and ufunc logs. Ufunc rounding decimals and ufunc logs. I'll see you there. Now here I'm on my PyCharm, so I'm gonna right click on this numpy ufuncs folder, create a new Python file, and let's name this as ufunc rounding decimals. Enter. Now let's say rounding decimals. 5 ways of rounding decimals. First one is truncate. Second one is fix. Third one is rounding. Then we have floor, and then lastly we have Ceil. Now let's see what is truncate. So this will remove the decimals and returns the float number closest to 0. Here we can make use of both trunc and fix. Let's see an example of this. So here first I'm going to import numpy as np, and then array equals np dot array. Let's not do array, let's directly do truncate and then pass the values. For example, if I say minus 6.1666 comma 6.6667 and then print array, let's go and see what output it gives. So I'm gonna run the file, and there we go. The output here is minus 6 point and 6 point. So if you can see, it is truncating the values after the decimal point. Let's try doing the same thing with fix. Array equals np dot fix, and then let me pass the same values to fix. Minus 6.16666 to 6.667 and then print array. Let's run and check if it gives the same output. And there we go. The output here is same. Now let's see what is rounding. So here the round function increments. Here the round function increments preceding digit or decimal by 1 if it's greater than or equal to 5, or else do nothing. For example, here we round off to 1 decimal point if the value is something like 3.1666 as 3.2. So here I'm going to say array equals np dot round and then 3.1666 comma 2 and then print array and hit enter. Let's run. There we go. You see the output here is 3.17. What if I change the value here to something like 6.223 and let's run. There we go. It says 6.22. So this is about how to round. So it will increment the preceding digit or decimal by 1 if it is greater than or equal to 5, or else it will do nothing. Else if I say something here 2.67, and let's check, this time it says 6.27. So this 67 is rounding off to 7. Only if I go and say something like 6.56, and now if I run, there we go, you see it says 6.56. Now let's see what is floor. So the floor function rounds off decimal to nearest lower integer. So here I say double R equals NP dot floor, and then here I say something like minus 6.166, comma 6.667, and then print array, and let's run and check, and there we go. So minus 6.166 is rounded off to minus 7, and then 6.667 is rounded off to 6. That is, it is rounding off to nearest lower integer, because here we have negative. It is rounding off to the lower digit, that is negative 7. Now let's see what is Ceil. So the Ceil function rounds off decimal to nearest upper integer. For example, here if I say array equals np dot ceil, and then negative 6.1666, 6.6667, and then print array. Let's run and check, and there we go. It says negative 6 and 7. So because here we have positive 6.667, the upper nearest integer would be 7, and for minus 6.166, the nearest upper integer is minus 6. Now this was about the ufunc rounding decimals. Here we have seen the 5 ways to round off the decimals, that is truncate, fix, rounding, floor, and Ceil. Now let's go and see what is ufunc logs. So I'm going to create a new file here. Let's name this as ufunc logs. Now let's see what are logs. So here I say numpy provides functions to perform log at the base 2, e, and 10. Now let's go and see log at the base 2. So here we will be using use log the base 2 function to perform log at the base 2. Let's go and import numpy first. Import numpy as np. Let me write the question here. Let's say find log at base 2 of all elements of the following array. Now let's say array equals np dot a range. I want to print numbers from, let's say, 1 to 10, so it means it will print numbers from 1 to 9. and then print np dot log 2 of array, and let's go and run and check, and there we go. This is the output. So this is 0, 1, 1.5, 2, 2.3, 2.5, 2.83, and 3.6. So these are the log to the base 2 values of numbers from 1 to 10. If I also want to see my array, so you can see it will give me numbers from 1 to 9. It's exclusive of 1 and exclusive of 10. Now let's see how to do the same with base 10. So here I say find log at base 10 of all elements of following array, and then here I say array equals np dot arrange. Let's say the elements are from 1 to 10, and then I would say print np dot log to the base 10 of array, and let's run and check the output. There we go. This is the output. 0.0.30, then 0.477, 0.62, 0.69, 0.77, 0.84, 0.903, 0.954. So this is how you can find the log to the base 10. Now let's see. Natural log or log at base E. So this was for log at base 10. So here we can use the log base 10 function to perform log at base 10. Similarly, we'll now see what is natural log or log at base E. So here we can use the log function to perform log at base E. And then I can go and say array equals np dot a range of 1, 10. You can take any range you want, not necessarily 1 to 10. And then np dot log of array, and let's run and check. So when you don't specify any base value, that is your natural log or log to the base E. So there we go. This is the output. Now what is log at any base? So NumPy actually doesn't provide any function for log at any base. So here I say NumPy does not provide any function. To take log at any base. So we can use from py func along with built-in maths.log function with 2 input parameters and 1 output parameter. So here first I'll be importing log from math by doing from math import log, and then import numpy as np, and then I do something like np.log equals np dot from py func log 2, 1, and then I can print my np log to which I can pass the value, let's say 115. Let's run and check. And there we go. This is the output, that is 1.70054 something. What if I go and change this to 10 and let's run and check? And there we go, it says 2.0 is the output. So this is about how we work with numpy logs that provides function to perform log at the base 2, log at the base e or natural log, and log at the base 10. So that's all for this session. In this session, we have seen ufunc rounding decimals, the 5 ways to round the decimals, and then we have seen ufunc logs and the functions to perform log at the base 2, at the base e, and at the base 10. So that's all for this session. Hope you enjoyed this session. We'll see you in the next.